guys, we're going to be looking at precision, accuracy, and error in this video. We're going to be looking at the differences between precision and accuracy, defining precision and accuracy, and then recognizing what error is and that it exists in all measurements. So let's start by looking at what precision and accuracy are. So precision is going to be basically showing how closely individual measurements agree with one another. How reproducible it is. So, like I said, our reproducibility of our measurements. And then we have accuracy, which is going to be how close an individual measurement agrees with the true or actual value. So what do we accept to be the true value? That accuracy, closer we get to it, the more accurate something is. When we think about a measurement, so measurements themselves should be both. So measurements should be both precise and accurate. Whenever we do a set of measurements, we want them to be reproducible. We want to get the same results every time. And of course, we want them to be close to the actual value, right? We don't want them to be wildly off. So if we think about accurate, again, that's getting as close as possible to the actual value, while precise is just getting everything the same, reproducible. And whenever we take measurements, we're going to take lots and lots of measurements. So when taking measurements, many trials are done. You don't want to have a measurement that is just a fluke. You want to make sure that you are getting that reproducibility. You want to make sure that your measurements are precise. And then, of course, generally you want to also make sure that they are as accurate as possible. And in order to do that, you have to take several measurements, which we call trials. So several measurements are trials. Okay? So when we take all these measurements, we're going to take and basically average those values. So the values that are obtained from the various trials are averaged in order to obtain a good measurement. Okay? And then we can express the precision of the measurement by something called standard deviation. Okay? So the standard deviation is basically showing how much an individual measurement differs or deviates from the average. So standard deviation. how much an individual measurement deviates from the average. That's the smaller that standard deviation, the more precise your measurement is. When we're taking measurements, we are the ones that are going to determine whether or not we're precise. If we take good measurements, make sure that we are using good lab practices, then we can make sure that our measurements are precise. But that does not necessarily mean that they're going to be accurate. So as a note, you can have very precise measurements that are not accurate. Right? One thing that could happen is you can have a tool that's not calibrated correctly. So your measurements will be very precise as long as you're doing them correctly, but they won't be very accurate. So when we think about that, that brings up the idea of an error. So anytime we have a measurement, there is going to be some error associated with it. So all measurements have error associated with them. No matter what, there are going to be errors that exist. There are two different types of errors that we generally see within chemistry. They are random errors and systematic errors. Our random errors are errors that are going to affect our precision. Random errors are going to be positive and negative in nature. So they're going to basically fluctuate below and above the accepted or true value. And all measurements are going to be subject to random error. It could be as simple as someone opening a door that could cause random error to occur due to airflow changing. And like I said, they're going to be existing in any type of measurement. But if you do enough of the measurement, if you don't do enough trials, generally you can average random errors out. So it can be averaged out through many trials. Okay, and then we have our systematic errors. And they're going to affect the accuracy of the measurement. And unlike our random errors, which fluctuate above and below, they are generally considered a one-sided error. So they are going to be repeated over and over again. So you're generally going to get the same error over and over again. This could be something like an instrument being calibrated incorrectly. So you can't just average these out by taking many, many measurements. This is a lot harder to deal with. But no matter what, you're going to have error, either random errors, you'll always have random errors, and then sometimes systematic errors. And because of that, we need to take that into account when we are expressing measurements. We have to understand that most measurements are not going to have an exact value, right? So when we give a measurement, or when we give a value, there will be uncertainty in that measurement because of these errors. So for instance, you may see some volume like 2.54 milliliters. What we're saying in that measurement is this last digit right here is uncertain due to possible errors. So this is our uncertain value. When we talk about a value that has some sort of uncertainty associated with that, we call that an inexact value. An exact value or number. So it's going to have some uncertainty associated with this, and any measured value is going to be considered inexact. And this is in contrast to what we call exact numbers. Where exact numbers are numbers where we have complete certainty in that value. So this is a certain number. All measurements are going to be uncertain, but we generally consider things that we can count. When we count objects, that's generally considered an exact number. So counted numbers. As long as our number is small enough. For instance, if we have a dozen eggs, 1 dozen eggs, we know that that is exactly equal to 12 eggs, right? If we have 1 kilogram, that is exactly equal to 1,000 grams. So these are all considered exact values. If I were to count the number of people in a class, so number of people in a class, that would be an exact number. Okay? That wraps up what I have to say about precision, accuracy, and error. I will talk to you guys later.